Okay, in theory, you can see the screen now.
Yes, we see it just fine.
Okay, so flash timing. Why flash timing? We've kind of talked about this before, but flash timing is really aimed at situations where someone has a camera which does not have timing built into it, but they want to use it for accurate timing of occultation. So that might, typical scenario might be someone who has a camera which is, they're using for other types of astroimaging, probably planetary imaging. If it's a camera that can run fast enough to do occultations, then it's more likely it was purchased to do something like planetary imaging, but it didn't have any timing built into it. And so this is a solution which would apply for someone that already has that camera that doesn't want to spend a lot of money on a new camera, which is designed for accurate timing. So a good way, as Michael was talking about earlier, a good way to transition for people who are doing other types of astronomy. We want to encourage them to do occultations. We want accurate timing with that. So there's been a variety of solutions built out there and done around using flash, GPS-driven flashes. And so for this one, I'll talk about this new design, which I'm calling the IOTA GFT or GPS flash timer. Let's see if I can right. So the components are pretty simple. Here it is, just plugged into a laptop. There's this little components held in a little box here, which was designed and printed, 3D printed by John Moore. The box has just a couple things plugged into it. There's a GPS antenna, and there's a LED holder which you would clip onto the front end of your telescope, which holds the LED, which would generate the flash, and then the device is connected to your PC via USB. And then on the computer that does the recording, you would have two applications. One is basically sort of a driver application that talks to the device. Another is called Fitz Reader. These were both developed by Bob Anderson and Bob. The Fitz Reader application is the one that reads the recorded video and adds the timestamps based on the flashes. So a lot of the motivation for this one was to do a more tight integration between the actual recording and the flashes. One of the more recently used flash devices is one designed by Art. In that one, you would pre-program the flash device with the times which you want the flashes to occur, and then you set up your recording separately to occur around the times of those flashes to make sure you record the flashes. With this approach, the flash device is plugged into the computer that does the recording, and so you coordinate and ensure that the flashes happen within the recording window. So the idea is to kind of eliminate one possible source of errors if you happen to, otherwise you might make a mistake in terms of setting up either your recording time or your flash times. So the current release is aimed at coordinating with SharpCap as a recording software. A lot of people are already using SharpCap. And so the current release is kind of tightly integrated with SharpCap and therefore Windows, and SharpCap runs on Windows. The driver software and the Fitz Reader application that Bob wrote can easily be ported into Linux or Mac, but in those environments right now, we don't know of any standard recording software that we would coordinate with. So at the moment, that's not part of the, we don't have any specific solution for that right now, but that's something to be added. So the basic operation, you attach the LEDs in front of the scope, you connect the GPS antenna to the device, you connect the device to the computer via the USB port. You'd start SharpCap on your recording computer. You acquire your target star, find the star, however you want to do that, plate solving, or just go to however you do that to get on your target star. You set your camera settings to the appropriate exposure and gain and all the things you want to be able to record. Then you start the driver application. And then in the driver application, you would enter the predicted time of the event and the recording duration. And then you'd hit this ARM UTC start button in the application. And then from there on, the application would drive SharpCap. It would tell SharpCap when to start recording. It would initiate the flashes, tell SharpCap when to stop recording. And at the end, it would then start up the reader application to convert all the, to add the timestamps into your recording. This is the user interface, current user interface for the device driver. You can see down the left side, there's some, just a couple fields where you enter the UTC date event date and time, and the recording length. You have some options to, you can either auto run that fixed reader program to add the timestamps, or you could run it later. You also have an option to shut down the CPU at the end of the recording if you were running this as an unattended operation, that you might want to have it shut down the CPU at the end of the recording, just make sure everything goes okay. Then you've got this ARM UTC start button. You have a variety of options you can display if you want to, and you have some options to talk directly to the device if you want to do any commands on your own. So, so kind of the current status real quick. We've been doing some beta testing, but we're ready for more beta testing now. I'll start building some more units after I get an idea of how many I need to build, how many people are interested right now. Right now I'm thinking we'll be able to sell assembled units for about $150. But then, all the code and the hardware design, the hardware elements will be available on GitHub. So if somebody wants to build their own, save a little money by building their own, they can do that. And another thing that we want to add, right now, the driver application kind of drives SharpCap, but some people have SharpCap sequences they built to do a little more complicated, a little more involved environments. Maybe like, I know Mike Skretsky's done multiple events per night using SharpCap with a lot of automation with plate solving and go-tos and recording intervals built into to do multiple events in one night. So we also want to be able to have SharpCap sequences drive the flash device instead, and that's pretty much in place. But again, it'd be good to do some more beta testing with that. So it'd be good to involve people with that aspect of the testing if they're interested. So as I said, Bob Anderson developed the software for the recording computer end. John Morris designed a 3D printer case and the LED holder. And that's kind of the end of the presentation. So that was just sort of a quick status on what's going on now. And if people have questions.
Can you program this completely before you leave home and then go out for a mobile station?
That is one of the goals, yeah. That's definitely one of the goals, is to be able to program the ARM UTC. And I say goals because I'm not sure what the current status is that with Bob and I've talked about that, and I don't remember where we are on if he's implemented that, but it's not hard to implement. Definitely, we want to have the ability for you to you would program that at the recording computer. You would tell the recording computer, since it controls the device, you would go in and run the application and tell it, okay, I want this to be the event time and I want this to be the recording interval. And then you want it to remember that so that when you get on site and you turn on that computer again, it already is set for that date and time and that recording interval. So yes, that is something we want to be able to support. But then also if you were someone that used the SharpCap sequences and you tend to prefer SharpCap to drive that, then yes, you'd be able to do that also from SharpCap by setting up the SharpCap sequence that had all that information. So yes, it's possible. It's just a question of which way you did it.
Steve, could you go back over the slide that represents how the app talks to SharpCap?
How the app?
Yeah.
Yeah.
You remember that?
How the app talks to SharpCap. Yes. Okay.
Yeah. Remember the cartoon where the scientists are scribbling on the board and there's all these equations on the left and the right, and then in the middle it says, and then a miracle happens.
Yeah. I'm not sure if I had one that really talked about it much, but the details are what do you, so the app talks to SharpCap. You run a script in SharpCap which opens up a HTTP port, opens up a port, and that's what the application. Actually, both of them open up. So there's dual communication between SharpCap and the driver, and they do this via TCP ports. And
okay, so they're talking to each other, but
right.
you tell the app when you
The app has a simple interface. You just tell it, here's what time my event is, and this is how long I want you to record. And
right,
then it'll drive
similar to IOTA video capture. I mean,
that's correct.
Generically speaking.
So that would help, for the basic scenarios. If you want to do something a little more involved in terms of doing a lot of plate solving and some of the more automated sequences like Mike Skrutsky's done, then you would want to have SharpCap drive the flash device instead, and then you'd use the back channel that way. And
right. But the simple way is you are the device would flash, and it would. How does the flash time get recorded, and where do you find it after the event?
The idea is the device driver tells SharpCap start recording now,
Yep.
and then a little bit afterwards it tells the device to flash.
Yep.
And then after the recording interval, it flashes again. It tells the device to flash again, and then it tells SharpCap to stop recording.
Right.
So all of the flashes are then encapsulated in the recorded video, and then it runs this. By default, it would run this program FitsReader, which reads the video files. And as this implies, I meant to put this in my presentation, but the default was right now. You need to record in Fits.
Yep.
That's what the program supports. But anyway, it scans through the video files, looking for the flashes, and then it then includes also, there's a log file that gets written that has all the times of the flashes from the device. And it combines those and uses that to determine the times of every frame, and then adds those times to the frames in the video, so that the end result is the video, which is timestamp.
Got it. So if you had 6 flashes at the beginning, it would look for 6 frames with flashes in them, and if it didn't find that, it would complain. But assuming it did, right, they would get updated, and then at the end, the 6 at the end, those frames would also get updated with the timestamp as well.
Right. There'll be a flash. By default, there's a flash sequence at the beginning and a flash sequence at the end, goalpost flashes, as we often call them. And then it finds both those flash sequences and then interpolates the times for all the frames in between. The same thing that gets used now by PyMovie, but now it's just integrated with single-purpose application.
Oh, so it will go and do the interpolation as well without waiting for PyMovie to do it?
Yes, right. It just outputs a video which has already got all the timestamps in it.
Oh, understood.
Right.
All right, that's good.
Unless it sees a problem. If it sees a problem, then it would, raise its hand and say, hey, we saw a problem, then you might have to go take a little deeper.
Got it. Very cool. Okay, thanks for that little explanation.
Sure.
Any other discussion?
Joan's got her hand up.
Yeah. My question is about interference with the recording. In other words, if you've got too many things running on the ports.
This is very low bandwidth, very low bandwidth. It's using almost nothing in terms of bandwidth, so it's not going to interfere with data capture.
Okay.
Data capture is going to be running at, 30
Right.
megabytes. This is going to be running at a few kilobytes maybe, so not a problem.
Okay. I want one.
Okay, yeah, all right.
Michael Camilleri has his hand up.
Yeah, I managed to rejoin. If it's already been asked, don't worry about it. Just wondering, so a couple of issues that I've raised about GPS flash time, and it's dealing with dropped frames and handling rolling shutter line delays. So how do you handle those with the IOTA GFT?
The drop frames would need to be detected by the FitsReader application, and that is a challenge. There's no, I don't know if the only way in my own looking at this, there aren't many ways to reliably detect drop frames just using GPS flashes. You could maybe flag it if you are looking at the system timestamps and if you start seeing breaks in that, you can flag it. I don't know if Bob has added that to the current fits reader application. Obviously, we could add that. The other thing, only other area I've heard of where you might, only other idea I've had for possibly detecting drop frames would be to use very long flash sequence. Basically, if each goalpost flash is as long as your recording interval, then you can use both those goalpost flash sequences as test. You know, if each goalpost flash sequence has the same number of frames during that interval, but then you see fewer frames during the actual event interval, then you would know, oh, I think we have a problem here because we should have had more frames in that interval. But
isn't that difficult to differentiate from jitter in the recording?
No, the jitter's normally at the sort of millisecond or sub-millisecond level on sharp cap. Drop frames, you know, if you've got longer exposures, typically
for a reasonably long exposure, it might stick out. You know, it could at least raise the alarm that something needs to be looked at. So probably the system-based timestamps would be the most useful approach. But yeah, that's something I don't remember if Bob has added that in yet or not. But yes.
Yep. What recording format are you using for this?
Right now, FITS.
Yeah,
that's based on and thus the name FITS reader. And again, I think that's largely driven by the fact that Bob wrote the application in Go, and I don't know if he has, and he did that because he wanted to be more easily portable to other platforms. And I don't know, the other format we would probably consider, at least based on SharpCap, would be ADV. And I don't know if there was a Go-based or how hard it would be to implement a Go-based library for ADV. Assuming it's easy, then it would not be hard to, and it probably is not terribly hard. But I don't want
my choice would definitely be ADV of the readily available formats. It's faster than FITS and more stable for timing, I think. Yeah, drop frames are a bit of a challenge. My suggestion would be to look at the timestamps on the individual FITS files or individual video frames to see if it looks like there's drop frames. And then sometimes it'll be recoverable and sometimes it won't be.
Right.
Will we have access to the unmodified file? That's
yes.
Okay.
Yeah,
because you could always feed that through SharpCap and see, through PyOte and PyMovie PyOte and see if they detect any drop frames.
Right.
Yeah. There's things there. So.
Steve, I can suggest a procedure for doing a correction for drop frames if you want to just contact me offline. I've got some ideas.
And again, I think Bob has looked at this. I just don't know what he's added. But yes. Okay. Yeah, it's pretty straightforward. Yeah.
Yep.
If there's system timestamps, it's pretty straightforward.
Definitely.
Out of curiosity, does SharpCap put a system timestamp into each FITS file?
I think the answer is yes, but possibly depending on how you configure SharpCap for that camera. So that might be the big challenge, trying to make sure that SharpCap is configured to add system timestamps to the file. And because
I always record in SharpCap with on-screen timestamps, so it gives me a clock so I don't miss my event time, and helps later in analysis. But your SharpCap will put timestamps on FITS files and on SEER video files and on ADV files. Right. Exactly what that timestamp means may vary depending on the recording format.
Right. Yeah, because there's some interesting questions about But versus drop frames, it's fine as long as it's consistent, meaning it's fine.
Yep. And the other elephant in the room, rolling shutter cameras. What do you have in place for dealing with the line delays? We
don't do anything about that because I feel like that's after the fact. You've got your frames. You would look at that in PyOTA after you do the analysis, and because all the frames, all the timestamps would be based on start of frame or start of the first scan line, if you will, of the exposure. Everything so all the timestamps are all based on the first scan line, and then when you do the analysis, then you have to do any adjustment for where the target star is located in the field of view. That's when you start doing the adjustment for rolling shutter.
Yeah, but that'd have to be measured for the individual camera.
Yeah, right,
It's not the same rolling shutter correction as for the run cam.
meaning,
Well, the analog video has every pixel is read out in a sequence in a defined time.
right,
So the line rate is just the number of lines divided by the exposure for an analog
right,
video camera, but that's not how the CMOS cameras read out.
right.
Yep.
But you can, I mean, you can adjust for this at the later stage. You don't necessarily need to adjust. I mean, the timestamps that we generate, the timestamps that we get generated by this would be the timestamp for the start of the first scan line. And then you just have to adjust for your actual event times have to be adjusted based off of that.
Yeah, it would be possible. I think I've had a conversation or discussion with Bob about this. It would be possible to analyze the line delays in
Sure.
Piety from the recording. It's just getting the routine in there and so that it operates. It can be done from a single flash. You can calculate the line delays.
Mm-hmm. Yep. So that's something people would do to understand their camera, ahead of time, and then use that to adjust their times later, I think. Yeah.
Yeah, it could be. I
And,
think it could also be built into Piety as an
yeah.
automated
So,
part of the process.
or maybe something that becomes an option in this. I mean, it could be an option later, but, yeah, could be an option. We have,
Okay, I'd like to move on.
I'll add one final comment, and that is, if you are looking to get into occultations and you don't already have your camera, get an Astrid. Don't mess around with flash timing.
Yeah,
It's a
okay.
good option if you already have your camera and you're trying to save a little money. You don't want to buy another camera. If you're going to buy a new camera, go get an Astrid. It's a very cost-effective way to do occultations and a very useful tool. Otherwise, it's much easier overall.
Great. Okay. Kevin Green, are you here?
I'm here.
Oh, great. Thank you for your patience, Kevin. And I'm eager to hear what you have to say about college and high school student involvement with occultation observations. So take it away, Kevin.
Trying to share screen. There we go. Okay.